Wait for it. And we're live. Hello, everyone. Welcome to the Geology Flannelcast, episode 54.
54, is that right?
That's right. Yeah, 54.
Oh, wow. Also, hello.
Yeah. Hello, I'm Steve.
We're 54 episodes in, still killing these intros.
Yeah.
A lot of controlled chaos here at the Flannelcast.
I was saying today, it feels good to be back. We haven't done this in 2 weeks.
Nobody knows that.
They
Jesse.
don't know that. We pre-recorded some episodes.
Yeah, we actually had a few in the can, if you will, as they say in the movie biz.
Yeah.
It shows how we're growing in that we just didn't disappear for 4 years again.
Yes. Actually, some of our Patreons are listening live right now, and Dennis had mentioned that he was just super happy that we came back from the dead. So, and then Jesse somehow took it full circle to dead bodies in a desert. So, if you want to be in on these very interesting conversations pre-recording, please look us up on Patreon, and you too can have a window into what is our universe prior recording.
Very scary window.
If you like and enjoy the show, feel free to support us on Patreon. Should we also
pay the bills?
Shout out to
our super awesome sponsor that's been with us basically since the beginning. We should start looking. I forget what episode we actually started recording commercials.
It would have been great if we could have segued before we started recording or before we went live. We were having a really thrilling conversation about Office 365, and that would have been a great segue.
That would have been a great segue because we were talking about how Microsoft Office 365 is you can do real-time collaboration on Word documents. So kind of like you do with a Google Doc where two people can actually edit it at the same exact time. Well, now you can do that with Word. I mean, you've been able to do that for years, but some of us are switching it over to Microsoft 365 and the OneDrive. So, but if you ever have any Word documenting formatting needs, you got to check out formattingformula.com or YouTube/C/formattingformula.com. They have hundreds of hours of videos basically explaining anything, table of contents to, those toolbars at the top, where it says like header, review, all that, you can customize those to make them look like whatever you want them to look like. Like if you do something all the time, you can actually customize those toolbars, and they have videos to show you how to customize those toolbars. It's ridiculous. So you think you're locked into just whatever they supply for you, but nope, that's not it. So it's not just insert, design, layout, reference, mailings, review, view, blah, blah, blah. You can actually customize them and change it up. If you do something over and over and over and over and over again for work, they can show you how to make it faster and easier, and you can look like a boss at your job. So check them out, formattingformula.com. Make sure you say that Geology Flannelcast sent you. Or even if you just watch their videos, just hit like, maybe post a comment that says, you heard of them through us. That'll hopefully keep them sponsoring us. So, yeah, formattingformula.com or YouTube/C/formattingformula. Check them out.
All right, on with the show. Well, we got a little action-packed episode today. We basically just kind of keeping it real in this episode. We got some news stories to talk about today, and then we'll see for the people there that are watching us on the live stream if you guys want to chime in. I don't know, ask some listener questions, or we can play Stump the Geologist, one of our favorites on these live streams. We had a pretty good one going last time we did a live stream a couple weeks ago.
Good interaction. You say you like it. It just makes me anxious.
You can feel the anxiety building. Just
it's literally like when I'm teaching and someone asks a question, I'm like, oh man, that's a great question.
Where is this going?
I'll get back to you next week, and then I just never show up for the rest of the semester. haven't been.
I think the answer's in the hallway. Let me go check. He just runs away.
It's like the classic Simpsons where the door slams and the car starts and heels out.
Yes, exactly. Oh.
Well,
So,
yeah.
Chris, real quick, how many
Yes.
downloads are we up to? We are right on the cusp of 200,000 downloads.
yeah, we're pretty close to 200,000. Pretty excited about that, but that's thanks to everyone that's been listening over the years and whatnot. Geez, I could check right now. Here,
No, I mean, you don't have to check right now, but I just basically wanted to shout out there that we're really close to 200,000 downloads. So if you like the podcast, subscribe to us on YouTube. All these little things help.
Yeah,
Yeah.
and you can find us everywhere. Twitter, Facebook.
we're at 197,000 right now.
Ooh, getting close.
So close to 200,000, but
Yeah. But on YouTube, if you just play it in the background, you can just have it in the background playing while you're doing your work,
Listen to our sweet, sweet voices.
Soothing voices. We can
Voices
talk
is-
smoother if it'll make it easier for you.
Goodness gracious. Yeah, I'm excited for that. We'll have a special episode.
Yeah.
No.
well, I guess we should keep this going on because this has kind of been a running story now at the podcast for the last little while. There's been a twist in this summer of 1992 story. Where I'm excited to see where this is going to go. So, in case you're a new listener, Jesse says in the summer of 1992. That was the year that what was the name of the volcano? Pinatubo?
Pinatubo erupted
Pinatubo.
in 1991,
1991.
which made the summer of 1992 cooler globally.
Yes.
And it is documented
It is.
that it was cooler. The
Um,
sulfur dioxide from the volcano blocks out sunlight, so dim the earth a little bit. This is all documented. It's proof of this. And so the summer when I was 9, turning 10, I was very impressionable. Summers were a big deal when 9 going on
Hey.
10.
Absolutely. That is a big deal. Because what are you, 4th grade and going into 5th grade?
Something like that,
Yeah.
know. And yeah, we didn't go to the pool much that summer, if at all. Some would say never.
I was going to
So-
say your tune just changed a little bit. That's what sparked this whole controversy in the first place. Is that Jesse saying they never went swimming?
I'm trying to be a little more conciliatory, but
I appreciate your neutrality.
so so that was 1992. Jesse was very impressionable. Fast forward to 2020. Jesse's still very impressionable to this day. Let me pull up this. So Jesse's brother Ryan chimed in and said that this is bogus and that there wasn't a summer that we went less to the pool.
And by the way, the only reason we're talking about Ryan right now is because he is a wonderful Patreon. So
That's it. That's the only reason we're
that's-
obliged to. No,
that's so not true, but it does help.
Now Ryan says that in July of 89 or 96, the average high was the same as it was in 92, and he doesn't feel that they went swimming any less in those years. So I guess he's starting to do some research now.
Yeah.
I want to point out he is not a geologist. So I do feel like
okay.
it's a small victory that I'm making him go research this,
That is kind of nice. Yeah.
drawing people in here. But also he didn't, in that email. Now you I don't know if you forwarded it, you just copy and pasted some of it. Did he cite where those sources? Did he tell us?
I gave you the entire message that he sent over.
So it could be fake news, is what you're
Yeah,
saying.
I'm just saying this is like Wikipedia citation needed.
Yeah, I didn't fact check it. I just said this is comic gold, and I just sent it right to you guys. I really couldn't care less about this, but it makes me laugh. If anybody's any climate data from 1992, let us know if you actually know what you're talking about out there.
Actually, 91 through 93, so we could really bookend.
We do.
Yeah.
I should have brought it. We had that. We had that. The one listener sent in the
It was like the weather of Pennsylvania
Weather
from
of Pennsylvania book.
yeah.
Yeah.
Oh shoot!
It was on Facebook.
Next,
But in that book, it references 1991 as being a hot year, and then 1993 being a hot year, and then in the 1993 citation, it says something like especially pronounced after the cold year of 1992 or the cold summer of 1992.
Yeah.
So. Yeah.
If you know anything about climate, which we don't, modern current climate, shoot me an email, chris@geologyflannelcast.com, and we'll talk.
Or if you worked the door at Ivyside in Pottsville, Pennsylvania, the pool.
Yeah. The year you were laid off. Because nobody came.
Tell me what the situation
Tell
is.
us about your 1991 furlough because of Pinatubo.
1992.
1992 furlough, excuse me. Jeez. Okay. All right. So that happened the other day. We gotta chuckle out of that. That was pretty fun.
So Ryan, if you're listening, thanks and keep
it
coming.
He said he listens to everything. He's just like
Yeah,
whatever.
I feel like he's taking notes.
I don't feel. I know he is.
What is that in Celsius, Chris?
So, all right. What news stories you guys want to start off with today? There's a couple cool ones. We haven't like I said, we haven't done this in a couple weeks. So
About the earthquake sensors.
Yeah,
that's a nice easy one.
I'm excited to hear about this because I keep seeing this headline in different places on the internet, but I haven't read it.
Oh,
so I'm
good.
gonna rely on you guys to tell me.
I'm just reading the Washington Post article. I'm not like, I didn't dive in any research papers, but
no, I don't. Just give me the bullet points here.
I read the Washington Post. I read this Washington Post article about an hour ago. So hour and 20 minutes ago. So let's jump into this. All right. So there is we have not just in the United States, but over the world, we have a whole system of seismographs set up, and it's to detect seismic activity, right? Earthquakes. And all they are basically just they're microphones that can detect like really low frequency sound waves, right? They can detect the vibrations in the earth, it's just sound moving through the earth. Think of like when there's an earthquake, think of the earth like ringing like a bell. And that's kind of what an earthquake is. All right. Very watered down, but but these seismographs don't only pick up seismic activity. Well, like I said, all this is considered seismic activity. They don't only pick up just earthquakes, I should say.
It's not just naturally occurring seismic activity.
Yeah.
It picks up anything that shakes the ground.
So this is how, like, for example, like we know when countries are testing nuclear weapons because they have a very distinct seismic signature. And there's all sorts of stuff. So one of the things that they started noticing across the world there's a bunch of countries here, some 27 different countries, is that the surface of the earth it became unusually calm when everybody started sheltering in place for COVID, which is really, really crazy. They can basically, they're not seeing as much background noise in the seismic data now than than the pre-COVID days. So, okay. So what's going on? Why is this happening? Well, just things like highways, trucks driving down highways, trucks driving down streets, things like that actually sets off very low. It'll set off the seismometers.
Yeah.
Right?
Have you ever been sitting in traffic and you're on a bridge and you're sitting in traffic, stop dead, but the traffic in the other direction is moving pretty freely? And you're sitting there, and then all of a sudden your car starts shaking up and down, up and down, up and down. Or if you're really old like me, if you've ever been walking in a mall and you're on the second floor of a mall, malls, these are these buildings with stores in them back in the day.
You with your fancy mall with 2 floors.
Yeah, I'm telling you, Grand Round Mall, God rest his soul. But you would stand there and you could actually feel the floor shaking. Well, these seismographs can pick this up. Like the article references, like if a FedEx truck slams on the brakes hard enough, all that energy gets pushed into the ground, and it can actually sense that FedEx truck stopping fast, or a bus driving by, or a truck driving by, or things like that. So they can be highly tuned instruments to pick up pretty much.
They're very sensitive, extremely sensitive. Yeah. And so one of the things is when you are installing one of these seismometers, you don't want these things to be near a highway, because there's so much noise coming off of a highway. It's just, there's going to be just too much background noise, and you're not going to really see the seismic data that you're looking for very clearly. All right. It'd be the same as like, I guess this is a horrible example, but like if you're somebody trying to pick up, you're having a conversation with somebody and you're in a football stadium or something like that with screaming fans. It can be difficult to hear. Right. So that's not the greatest example. I don't know why I said that, but
but it's funny because some seismographs actually pick up events like football games.
In Seattle.
Yeah, like when they score a touchdown or something, it actually sets off the seismographs nearby because everybody jumps up out of their seat.
Yeah, I thought I read something that where the Seattle in the newer Seattle, I guess it's where they play the football games now. It's like the loudest in the NFL. It just has these like crazy acoustics.
They call it the 13th man.
Yeah. And they can actually pick up when there's a football.
12th man. Sorry, carry on.
They can actually pick up on the seismograms when there's a football game on Sunday afternoons or Sunday evenings. It's just all of that noise just kind of gets the seismometers pick it up.
Yep. So yes, Dennis, they're that sensitive. We're getting a few comments in here. The interesting story. So Temple University had an opportunity to be part of the East Coast Seismograph network, and the Temple University opted to not put it on campus because campus
the main campus.
Yeah, the main campus is because it's sandwiched between the Broad Street subway line, which is a subway line, and another train line, which is not far away. So every 4 minutes or something, there would be a train going by and setting off the seismograph. So unless you had an earthquake that happened to hit between two trains, that signal might have gotten muted. So they actually, it's still on a Temple University campus, but it's out in the suburbs, out near Jesse.
Yeah, and so that was the thing, and even there, I thought they said that it wasn't like the most optimal spot because there is still a fair amount of noise.
Well, it's funny because it's actually right next to, like soccer field.
Yeah,
and so when there would be soccer games, you would pick up the vibration of all the feet.
No kidding.
Was running, but it's actually gotten a lot quieter because they've moved the soccer games down onto campus.
Oh, okay.
Main campus, yeah. They built a new stadium.
So I'm reading this article, this Washington Post article. It's pretty neat. They're saying the most dramatic effect from COVID was seen in Sri Lanka. And a seismic station in Sri Lanka saw 50% reduction in background noise.
Holy cow.
Yeah, it's like, well, it's half. And then in New York City Central Park.
Thanks for explaining that math to me.
I can divide by 2. That's one thing I can do. In New York City Central Park, the article says that sound was decreased at night by 10%. So New York's pretty happening place.
Does that take into account all of the fireworks that everyone ever is shooting off?
Ever?
The number of fireworks
really
in New York City is New York City especially, like there's conspiracy theories popping up about this. It's not so much I think everyone kind of after the 4th are out of money, I assume, because fireworks are not cheap. But even like here in Philly, like leading up to the 4th, like from May onwards, like every night, like if it was cool enough, we'd have the back door open, and you just hear like boom, 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 and like
when I lived in Upper Darby, it was basically as soon as it got warm, like late March until October.
But I guess that probably wouldn't because that's in the air. So I wonder what a
I
firework.
don't know. Some of those big like kaboomers things, that the ones that kind of just give off sound. Yeah, that's right. It's a technical term, kaboomers.
A big kaboomer. That's good.
Yeah.
I think that's military term, right?
Yeah. Now, you guys, any of you play Atari?
I mean,
Yes, Atari
No.
2600.
Yeah. Do you remember the game Kaboom?
No.
That was one of those games where, do you remember the paddle that had like just the wheel?
Yeah.
Yeah. Oh man, that was a great game, Kaboom. If any of our listeners out there are old enough to remember Kaboom, send us an email.
Or an Atari 2600. I'll take.
I have an Atari 2600. I
What?
just, yeah,
That'll pay for one of your kids to go to college.
probably not.
I don't think
I have like 30 games and they're all like the worst games ever. that
E.T.
nobody wants.
Was
No,
Atari the one where,
E.T. was terrible.
Yeah.
Man. I remember we had that game and I think we like threw it out like a month later. Like this is stupid.
that's a legendary. I remember that's like on Sega Genesis. There was a game called Michael Jackson's Moonwalker.
played it.
Oh man, that
great.
game that was terrible. It was a terrible. I don't know. Couldn't ever figure it out. I'm sure my brother will probably send an email saying, "Nope, we actually beat it." And
maybe you played it all summer of 1992.
yeah. We would, this is going to age us here. Aside from talking about Sega and Atari 2600, we used to walk down to the video store and we'd rent a single game for the weekend or whatever.
Yeah. So those youngins are still listening. Atari 2600 was like probably the first big commercial hit for a home video gaming system. There were a couple before it, like the Commodore 64 and Pong and things like that, but Atari 2600 was really where it like took off. So there, take that.
First here, turning into
PlayStation 4.
Entertainment history podcast.
Listen,
All right.
a lot of my youth was spent playing video games.
Mine too. So anyway, the coronavirus shuts down.
So
seismometers are very quiet now because people are not moving as much.
We need to write a paper about the correlation between the increase in coronavirus cases and increased seismicity.
They
Boom.
just did. Increase in seismicity.
Yeah, so you can predict that coronavirus's cases are going to increase based on the increased seismicity.
The lag,
Yeah.
So
Shoot, I just told the entire planet this now. So there goes my
an
idea.
uptick in seismicity, and then you look at corona cases like 2 weeks later.
Oh, I see what you're saying.
Bam.
Yep, there you go. Big Brother's gonna love that one.
And our live stream just cut out.
All right. Moving on.
Yeah, but that's really interesting that I have anecdotally seen also articles about the atmosphere being cleaner and lot less air traffic and less noise pollution. So, there's always a silver lining. You got to find it. Less earthquakes.
Yeah.
It's not that there's less earthquakes. It's not what the article was saying. It's just saying that people aren't moving around as much.
Nope.
It depends on what you call an earthquake. Seismically active crust. How's that?
Yeah. We're not talking about fault movement. We're talking about the earth actually shaking.
Yeah.
You can send all your emails to Steve at Geology Flannelcast about this topic. He will be more than happy to check that out and respond to you about his earthquake threshold.
I'm on it.
All right. The guys here that Venus was in the news.
It was in retrograde.
Yeah.
Venus was in retrograde. I don't know if Venus was in retrograde, to tell you the truth.
I honestly don't even know what that means.
Saturn did something funny. But anyway.
Retrograde means
you can see Saturn.
Yeah.
But sorry, carry on. Retrograde means
you can see Saturn often.
Retrograde means that you're looking at the planet like over time, move across the sky, and then all of a sudden, then it kind of just goes backwards for a little bit and then goes forward again.
Wait, really?
Yeah. It has to do with just how the Earth is in its position going around the orbital disk around the sun. And then it's all perspective.
Ooh.
So like the planet's not like changing or anything. It's just a perspective from where we are in our orbital path.
Hits the brakes, hits reverse.
It hits the brakes, was like, oh, I've left something back there. And then, no, I'm good. So that's what retrograde means, is when the planet's moving. It appears that it's moving backwards, but it's all perspective.
Dennis confirms that for us.
Thank you, Dennis.
Oh man. And I'm not going to get into, I'll let you carry on with Venus here. But yes, Saturn, like Steve was saying, you can see right now, it's pretty bright in the sky. But there was something, it was doing something funny too. And I just Googled it really quick because that's the kind of research I do. And I just pulled up a thing about Saturn's rings spin the wrong way. I'm going to look into this. I'll get back to you. Anyhow.
Maybe we can ask our Patreon, who's actually an astronomer.
Yeah. His responsive questioning ellipse tells me maybe I'm not onto something here. Astrology.com tells me no.
What do you like? I just imagine you're like Miss Cleo with your tarot cards, just flipping them over.
Oh man, I forgot all about Miss Cleo.
That was all fraud. She I don't know. I don't know if she
was she like did she have a commercial? You're a Libra, aren't you, darling? And she would have like a 1-800 commercial.
Yeah, it was all money. Yeah, I don't know.
Call me now.
Yeah. Anyway, talk about Venus.
All right, close out the coronavirus tab. All right, so Venus is really interesting. So I'm going to preface this by saying I'm not like a planetary geologist by any means, nor do I ever pretend to be a planetary geologist. I am a coastal geologist talking about planets here. So bear with me for a second here. It was apparently Venus was thought to not be tectonically active, or its tectonics shut off a while ago, like a really, really long time ago. But there's a new paper out that says that scientists identified 37 volcanic structures on Venus, and that these volcanic structures have been recently active and probably still are active today. And so they're thinking like, well, maybe Venus isn't as dormant as we thought it was. So they found, these researchers were looking at these like ring-like structures that you can see from some remote sensing data orbiting Venus, and they're called coronae. And what it is an upwelling of hot rock from deep within the planet's interior.
Yeah.
And so they basically,
isn't an upwelling of hot rock from the Earth's interior a volcano?
Yeah, but
it's also not coming from the Earth's interior. It's coming from Venus's.
The Earth. It's not going from the Earth shooting across. That would be amazing, though, if that happened.
There goes all of my credibility. I will be over here.
You can't lose credibility if you never had it to begin with, Steve.
Shh.
All right. So, like I said,
damn it, he found me out.
So that's pretty cool. This is published in Nature Geoscience, and so basically they started looking at some radar images of Venus from NASA's Magellan spacecraft in the 1990s, and they found these coronae on there. And of the 133 coronae they looked at, 37 looked like they were active within the last 2 to 3 million years. So a blink of an eye within geologic time. But and it basically. These coronae, Steve, you asked, is it like a volcano? Well, these coronae are basically lava flows with major faults within them spanning a large circular area. So the biggest one that they found was 1,300 miles in diameter.
Whoa.
So, yeah, that's pretty
big considering how the planet's not that big.
No, Venus is the sister planet to Earth.
Yeah.
No, I understand, but I'm just like, but could you imagine that on Earth? That's gigantic.
Well, I mean, that would go from New York to Denver, right?
Yeah.
That's about, because it's from New York to California. It's like 3,000 miles, right?
I know it's like 1,000 miles from here to Jacksonville, Florida.
Okay, so
we're
then
gonna get emails about this because these numbers are not.
Yeah. What is it in meters? That's what I need to know.
I've walked from Jacksonville to Pennsylvania.
Yeah. What's his name's doing that? Howard Eskin.
Why?
Why?
Because the Super Bowl is in Jacksonville this year.
He's gonna be really disappointed when they cancel all the sports in a couple of weeks.
No, he's walking the equivalent while he's in quarantine.
Okay. So
It's for charity.
I was just about. Okay, then I won't say anything disparaging about him.
Yeah, I'm not a big Howard Eskin fan either, but
nobody outside of Philadelphia knows who Howard Eskin is. So let's.
Yeah, true. He's a sports commentator or a sports journalist,
radio personality
slash everybody, someone that everybody loves to hate.
Yeah.
So there you go. Venus looks like it's volcanically active. That's pretty cool. So it's not just before. Well, we just thought it was the Earth because there's the Olympus Mons on Mars, but they don't think that Mars is tectonically active, and it used to be, and it's no longer tectonically active.
So are they theorizing that the volcanism is from just like the planet being squished from being so close to the sun or closer to the sun?
They didn't say that. They just thought that, there's still something's going on in there. The inside is still really, really warm. And it's that hot rock is able to kind of move out to the exterior to have volcanic activity is the gist of what what I understood from this.
It always blows my mind with Venus too. Like, so Venus is closer to us than Mars, and it's Earth's sort of evil twin, same size, because it's so inhospitable, and so like we have a really tough time seeing like the surface of Venus because of its atmosphere. And because its atmosphere is essentially 98% carbon dioxide. It had this runaway greenhouse on it. And that's why it's super hot, and it's got this really dense atmosphere. And so we have a really tough time imaging the surface of it. That's why we have to use things like radar.
So we shouldn't worry about Martians. We should worry about Vesuvians.
Yeah, that's what I'm saying.
Right. They're just hiding out under that blanket, waiting.
And there's the story about the Soviets landed a thing on the surface.
Yeah, but didn't it last like 8 minutes or something?
Yeah.
Well, there's so much pressure on the surface. I'm looking it up right now. It's
you would get crushed. Dennis is telling us what a Vesuvian is really called. Venera.
So the surface of Venus is 477 degrees Celsius. I know that it's hot enough to melt lead at the surface of Venus.
It's hot enough to what on the surface of Venus?
Melt lead.
Oh, that's hot.
Yeah, that's pretty hot. Yeah,
I mean, you would probably. Venus is the same root as love as venereal. So, okay.
Yeah.
So venereal disease is a love disease. Okay, we're learning things today.
Yeah, man.
Learning things today.
Yeah, that's where it comes. Yeah.
It's so hot right now. It's a Zoolander reference from 20 years ago.
It'll melt you.
It's not the 90s or the 80s, Chris. You don't have to keep tally on that one.
Oh, I wasn't. I'm trying to figure out. There's a number out there that if you were standing on the surface of Venus, the air pressure, the pressure alone
would crush you.
Is equivalent to like so many meters of depth in the ocean, the Earth ocean.
Well, you could do that. Do the conversion.
I'm looking.
What's the surface pressure?
90 bar, it says. The pressure on Earth is 1 bar.
Yeah.
This website I'm looking at says 90 bars.
You could do just, how many bar at, I don't know, 10,000 feet below sea level.
I don't know. We'll figure this out later. This is
this is one of those things where like, oh, it's probably easy to do this math, but not on the fly.
when we have thousands and thousands of listeners listening right now. Speaking of which, the listeners, so Benjamin says that it is 1,200 miles from Hartford, Connecticut to Vero Beach, Florida. So that's a good chunk of the U.S. Eastern Seaboard right there.
There you go.
I like Hartford, the whale.
I've been to Hartford.
Yeah, big fan of Hartford.
So I gotta let's do this. Will be fun. So let's see. George sent a listener question. So for anyone else that's out there listening, wants to chime in, give us some questions. Here's a good one. He goes, do you think that future geologists will be able to see 2020 in the climatic record, or that the 90 days of reduced movement is too short to be seen by future scientists? 90 days of reduced movement. Oh, do you think that's 90 days? Is that 90 days of just like us not moving around from
activity.
COVID?
Yeah.
Yeah, I think that's what he's asking.
I think it's way too short to be seen in.
You think so? You don't think think of like lake bars and stuff like that, or ice cores. You don't think that reduced anthropogenic input would be noticed?
That's interesting. That's a really interesting question. Like, could you see? I don't know. It's 90 days is because they're already seeing like atmospheric pollutants and whatnot starting to rebound. In 90 days, that's only a quarter of the year. Gosh, that's a really good question.
But I guess the question would be, it'd have to be in a setting where you see that, and then there's not that many settings on the surface of the Earth where you can get like annual resolution.
Yeah. And you know what? Probably where you do like in an ice core or something where you do get annual resolution, what it would show up as is like a muted average. So like where you would see things going up, and then it might be like that year is a little plateau before it keeps going up, or the rate of increase won't be the same as the years preceding in the years.
Who asked that question?
It's on YouTube, George.
Right, George, great question, man.
Yeah, George, our buddy from Facebook. Good question.
I'm.
Good question.
I am intrigued. This is another research proposal right here. Boom.
This is going to be something in like 10 years. People are going to look at the previous data and see this little pause or this little plateau and be like, "Nah, climate change isn't happening. See?
It's fake.
It stopped in 2020." What did you say the density was on Venus? I've already forgotten.
80 bars, 90 bars.
The pressure, I said 90 bars.
90 bars.
That is nothing.
Well, let me double check it then.
At the bottom of the Mariana Trench is 1,000 bars, almost 1,100 bar.
Maybe I got a wrong number.
Surface pressure is 92 bar.
Okay, so that's from I got the
much more.
That's still a lot of pressure.
So what's the depth? What's the ocean depth of 90 bar?
Well, now, gosh, yeah, I'm pretty sure, like Dennis said, it would crush a submarine. But you're not factoring in that I'm stronger than a submarine?
Or is it James Cameron's submarine?
Ooh, good question. Good question.
Here it is. I got the, let's see, bar.
Okay.
Bar. Oh, this only goes up to 100 meters is 9.8 bars. So just...
Yeah,
if it's linear, then it'd be 1,000 feet of 1,000 meters of
ocean. Yeah. Well, which would kind of make sense if 10,000 feet is 900 bars or 1,000 bars.
Yeah, I will have to. I'm very interested in this now. So,
yeah, those of us who are listening and have time to Google, but.
I'm sure someone's got there's got to be like a calculator somewhere.
I'm sure. But back to George's question, I would like to think that there have to be some depositional proxies in the near term that could pick up a 90-day differential if it was significant enough.
1,000 meters of Earth's oceanic pressure. Found it. Boom. Settled. Continue.
Didn't we just say that? Who's going to be?
No, I
about
said,
1,000? All right.
no, I just found another source.
Is
Right.
is it? I guess it's linear. Yeah. There's got to be things, and they're always coming up with crazy new proxies, and technology is.
Dennis, clap for us.
Yeah, technology is such that the sensitivity of these things is. Yeah, I bet you you'll be able to see it.
That's what I'm thinking too. So, all right. In episode 512, we'll come back to this.
Yeah.
And we'll check it.
Yeah. So I've got a story here. Do you mind if I
Jump on in, buddy.
Stage is yours, my friend.
so
Jesse's corner.
I got gears to grind.
I just like how our show's just morphed into nothing, but it's just our show is Jesse's Corner now.
So a couple episodes ago, I have no idea. Time has no meaning anymore in lockdown. We talked about plate tectonics and sort of the idea about when plate tectonics started. Maybe I did it, or I don't know if it was on an episode or if it was just one of my corners. That story was passed along to me by longtime listener Vince, and I didn't give him a shout out apparently because he sent me a message.
So now you pissed off one of our listeners.
Dang.
Very good.
Essentially, thanks for the shout out. So like, well, I can't tell sarcasm over email or text, so
Yeah, it's hard to infer tone.
I'm just going to assume you are grateful. You're welcome.
You're welcome.
But anyway, so I'll give him a shout out now as I delve into this story. So there's a new idea.
Thanks, Vince.
Thanks, Vince. This isn't Vince's idea, but it could be. About the beginning of plate tectonics. And I had to reread this story because boy, is it sort of out there. But it was just published in Nature Communications. So, I mean, it's legitimate. It's not like I'm on, again, astrology.com.
But so you are on astrology.com.
Yeah. So the idea is that plate tectonics started when basically the plates formed, these fractures in the lithosphere formed due to thermal expansion. That I see Chris typing furiously. I think here's the thing the source. So basically, when the early Earth formed, it's all hot or whatever, and then the outer surface starts cooling off because it's just losing heat to space, and it cools off pretty quickly. But material from depth gets pumped up through volcanism. Shout out to Mark here. Volcanoes in all caps. Brings all that material up. And so what happens is that material comes up to the surface and spreads out on the surface, but then also cools down really rapidly because it just loses heat to space. But as you pile this material up, it starts pushing down on the asthenosphere. And so you have all this basically really cold shell that's pushing down on the asthenosphere because it's cold and it's dense. And there's a heat transfer because the early interior of the Earth is very hot, that heats it up. And so eventually the volcanism slows down. They don't really go into why it slows down, but the idea is that you have this thick, cold shell that because of conduction heats up and it causes it to expand. And you don't need much expansion because it's rigid and it's brittle and it's hard. And
so kind of like that's the reason that they have the lines in sidewalks, right? So that the sidewalks can expand. And
or
it doesn't.
You go across a bridge and it's got
those
strips.
Yeah. Exactly.
Yeah.
So
Called
that's
expansion joints.
Thank you.
Yep. So they're essentially, if it expands enough, and they're saying here, you only need expansion of about 1 kilometer.
That's a lot of expansion.
But over the
But I
whole
guess-
planet,
Yeah.
That's a lot. Like, no, I'm just not used to thinking on that type of
Yeah.
on that type of scale. Like,
But that would be enough to cause cracks, and you would get these fractures that would create this network that would just grow. And that's, they think, the initiation of the breakup of the surface into these different plates.
huh?
It's sort of, a lot of it is modeling based.
Yeah. No, it's just because so rock is like horrible at conducting heat.
Yeah.
And so it's
Part of the reason the interior of the Earth is still really hot. I mean, we get a lot of heat is left over. We get a lot of it from radioactivity, but a lot of it's left over from accretion, just because Earth is a big insulator. It's a big thermos, big mug. That's how I always think about it. Like my cup of coffee. My cup of coffee just gets cool on the surface, but down below it's still really warm.
mm-hmm.
Yeah, so I thought that was interesting.
Yeah, that's yeah, that really makes me think. It's interesting to kind of think about something on like that large of a scale. Like you said, like it took a kilometer of expansion. I wonder if there would be like, if it would start off as like small cracks and then kind of led into more or less the plate boundaries and like the fault systems that we see today. But but I guess like, so, you know, it's really hard to think about like really early, like, you know, in Earth history, like, you know, thinking about the start of, you know, plate tectonics and you know, the Archean eon or whatever. And it's just the hardest thing is just trying to imagine what the landscape was like.
Yeah.
You know?
Oh gosh.
It's, man.
Sort of hellscape.
Yeah. Because at that point, let's see, I would imagine
we're in the Hadrian here. We're not even the Archean yet.
So then the oceans hadn't formed then.
No.
Yeah. Actually, that's great. Yeah, no, I don't think
the oceans formed in the Archean.
Yeah.
Once things cooled down enough and the clouds could condense and yada.
You want to talk about a monsoon? Choo.
Yeah, right. That's really interesting. So,
yeah, I don't know. Maybe I'll read the Nature Communication paper and.
Yeah, it's probably short.
Yeah, that's a good point.
All right.
Cool. Anywho, that was my story on plate tectonics.
All right, we got another question from someone here on YouTube. Oh, we got two. Okay, so Maddie came first. Maddie asks, I love Maddie. You're the man. Maddie wants to know. I guess I vaguely remember on the last live stream we had. Maddie had a question like last second, and basically thought we didn't have time, and we. So now Maddie's demanding an answer, come hell or high water.
Well, it's a shame we're running out of time.
Yeah,
now,
sorry, Maddie, we're out of time. It's been great. Snooze, you lose, Maddie. Maddie wanted to know what's the verdict on mass extinction from the last stream, meteorite or volcanic. So he means like the end of Mesozoic, start of Cenozoic. Mass extinction, the KPG as you would call it now, right?
So what is he saying? Like gun to our heads, pick one.
He wants to know meteorite or volcano. I'm going to go with meteorite.
It depends on who our next guest is.
Depends who our next guest is.
No, I
think the consensus is more and more meteorite.
Yes. There seems to be more and more evidence that the volcanism was definitely having an impact on their ecosystem. But no matter how weak their ecosystem was, the impact would have been the nail in the coffin regardless. Does that make sense?
Mm-hmm.
So they were already on the decline, but even if they weren't on the decline,
I think there's been some studies showing that there were like some diseases. Like basically, like the dinosaurs were pretty much on the way out, like you said, Steve. There was just kind of like there's like some kind of, I think I heard like diseases going around with the dinosaurs, and if the asteroid didn't take them out, something else would have, is what I've heard.
I mean, just the evolution of the planet. Yes, stuff dies. Like it's just nothing's really lived forever.
Except for sharks.
like horseshoe crabs or something.
Yeah.
But, like,
satellites.
Yeah. All right.
Yeah.
So yeah, there are a few things that have survived for a really, really, really long time, but
that's like the rarity.
Yeah, that's the exception more than the rule. So yes, chances are dinosaurs were going to die out of something, but the asteroid impact it was just too devastating over too much of the planet for anything that big to survive. So
yeah,
yes,
that's just as someone like like I said, this once again, this isn't my field of study, but I just I kind of read up on it just because I think it's really cool. It's really interesting to hear some of the engineers that get involved with the ballistics of this asteroid hitting Earth. And it seems like there's a couple different models going on.
Engineers or physicists?
Like engineers, like working on like people with engineering backgrounds working on the ballistic properties of this thing coming into Earth at like Mach 50 and slamming into the into the Yucatan Peninsula, and it's got some pretty cool results. Like I said, actually, if you're really interested in this topic, one of the coolest things that I heard, there's an episode of the podcast Radio Lab where they go into detail.
Don't direct people to listen to other podcasts.
Why? I listen to like 20 podcasts. It's totally fine.
No, just listen to our entire backlog of podcasts, and I'm sure we cover it.
No, that is a good episode, though.
Yeah. So I forget what the name of the episode is.
Radio Lab, if you want to be a sponsor of the Geology Flannelcast, please give us a shout.
This is like the second biggest podcast in the world is going to give us a shout out.
Hey,
but we're out there. I'm a fan. So I would say, anyways, to answer Maddie's question, I go with meteorite or asteroid.
Yeah.
No, meteorite.
Yeah. Meteor wrong?
Once it hits the surface, it's a meteorite.
Technically. Yeah, but
meteorite. Well,
but what, Jesse?
What? It's bigger than a meteor. The thing that hit Earth wasn't a meteor, it was an asteroid.
But I thought technically once it hits the surface, it's a meteorite. Regardless of how big it was before it hit the planet.
Gosh.
You're really
I'm just
no, it's true. These are the semantics here. Yeah, so once it hits, it's technically a meteorite. Yeah, if it's big enough, it's an asteroid, especially if it's orbiting between Mars and Jupiter.
So they call it an asteroid impact?
Yeah.
Or they call it a meteorite impact?
I've always heard asteroid impact for this one.
Yeah. I think if it's big enough, it's an asteroid.
Yeah, I think that's I would go with asteroid. It says asteroids are smaller than a planet.
I'm sticking to my guns. I'm saying meteorite.
All right, I like it.
All right. Steve at geologyflannelcast.com.
Hey, we can get a little poll going right here. Type in the comments. Do you think it's meteorite or asteroid impact?
Yeah.
Well, I don't know. I think this asteroid impact just kind of, like I said.
Either way, Maddie, excellent question. Thank you, buddy.
All right. Let's see.
Yeah.
We can, let's.
How are we doing on questions?
Because we got another YouTube question here. Maddie says, Maddie said he saw it. There was a scientist in Princeton showing evidence for volcanism.
Yeah, Gerta Keller.
Yeah.
Yes, and she has done extensive evidence, and there's all kinds of, I think it's mercury deposits from the Deccan Trap volcanisms that essentially, like Chris said, probably would have killed off the dinosaurs, but the meteorite impact did it first.
Yeah. Yeah, and she's done a lot of really interesting work with like the timing of the Deccan traps, but I'm not really buying that it was the main cause. Asteroid, got him.
Meteorite.
Meteorite.
Got him.
All right, so I got another question. We gotta get the hell off this topic.
Anytime I stick to so for those of you who are listening, we're live right now, but right now Chris would be marking down on his little whiteboard. I need to edit out Steve here. I need to edit out.
I didn't know. It's totally clean. The whiteboard is totally clean right now. These live podcasts are delightful for me. Okay. Let's see. H. Glenn asked if on our YouTube chat, if Venus is still active. This is a good thought experiment. You guys ready?
I'm excited.
Okay, just excited. Here we go. If Venus is still active, we could expect more diverse minerals than a geologically dead planet like Mars, right? Repeated partial melt, mixing, metamorphism, etc. What do you guys think? I saw this question a couple minutes ago, and I got a little head start on you guys.
Yeah,
so,
no, please.
That is a really.
It's an interesting point, right?
Yeah.
Let's take a step back. Like, what leads to more diverse mineralization? Is it temperature, pressure? Is it both? Is it the ingredients? Like, we have different ingredients of Venus because whatever the moon was that hit us and all that stuff. And
if you're flying over Earth and you're looking, say, just at volcanoes, would it look mineralogically diverse?
No.
I don't know.
Just looking at volcanoes. Well, there is a diversity of volcanoes.
Yeah, but you're talking like rhyolite, basalt.
I mean, if you're looking from 100,000 feet up, is that what you're saying?
Yeah, I don't know. I'm just curious. It'd be interesting. Yeah.
That's a great thought experiment because
there's, but I guess my argument would be that there's diversity from like, whatever, felsic volcano to felsic volcano or, magma plume or, whatever.
I think my answer would be yes, but could we detect it given what we have?
Yes, but with the instrumentation that we have.
Yeah.
I don't, you never hear about Venus in the news. Everything's about Mars, we're setting up all these
because
Mars
no one
rovers.
Because you can't
because it's a pain in the butt. Yeah.
You can't see anything.
Yeah.
And even with Mars, like the rover that's up there now and the new one that's going to land in 2021 that they just sent up.
Yeah.
They have special probes on them to like grind a little bit of the surface, and they have an XRD arm on it to look at the mineralogy. Because a lot of the earlier probes, I don't know if they had XRDs or not on them.
I don't think they had XRD or XRF before. But
Curiosity, one of the last one that's still up there.
But with our planets being essentially the same size and volcanism essentially going on the same amount of time, like even if it stopped 2 million years ago, 2 million years, like Chris said earlier, is a blink of an eye. The only difference would be the extent of volcanism and the ingredients. And if our planets are the same size and a relative same position away from the sun, the only difference I could see in the ingredients would be if that impact that created the moon actually gave us something different. So yeah, I don't know. That's a good thought experiment.
I would also attack this question from another angle too. So let me pull up the question real fast.
I'm excited to see what angle this is.
Okay. So theoretically, right? So let's just say that for the purpose of this thought experiment, that Venus wasn't tectonically active, right? Like what we thought 2 weeks ago or whatever before that article came out, right? But there was still tectonics going at some point. Well, wouldn't the fact that there was tectonics, it would create all the difference all your different minerals. It would do that whole thing, go through the whole rock cycle, all that jazz. But then everything just shuts off. But it was still there at one point. And then if tectonics shut off.
Yeah, I'm listening. Sorry. I'm just making noise.
You sound like a dog that's like hungry right now. If you were to just shut off the tectonics, you would, I guess, the only rocks that you could get developing you would have sedimentary processes theoretically to an extent. But
not much.
But that's because I'm just trying to think that's what they see on Mars right now.
But you wouldn't have.
But it's there. All the minerals are already there.
Yeah, but you wouldn't have a hydrologic cycle. You wouldn't have much water because it would have evaporated like instantly. So you're not going to have any hydrated minerals.
Okay.
You're not going to have much sedimentation and lithification of stuff. So those type of sedimentary.
Well, I was just saying, like, you're getting basically geomorphic changes on the surface, and that's it. But
yeah,
that stuff that's already making up the crust of Venus already went through all of those processes. So does it matter with the extra? I don't know how long they thought that tectonics shut off, but it didn't. But if tectonics shut off 1 billion years ago, you still have all those minerals in your crust, unless somehow they were chemically altered. And if you have like I guess, but maybe you're not getting the weathering that we would. It's.
You have a ton
geology makes me a headache.
You have have a ton of CO2 in the atmosphere, so maybe the CO2 is affecting the mineralogy.
Sure, we don't. That's the thing. That's the thing that's so wild about planetary geology is that you literally have to change your thought process. And like everything is different. It's not Earth. There's like it. Yeah. It's totally, even just like playing around with a little bit of the geology on Mars. It's just like, it's a whole different game. The gravitational constant's different, and like just everything that changes everything. Not everything, but a lot of stuff with just the sedimentary processes, and we just, even if you just try to compare the Earth today, the surface of the Earth, you can't really compare that to any other planet because we have vegetation. That changes your landscape around completely. So planetary, it's fun. It's always a fun thought experiment when you're dealing with planetary geology, just to try and like alter your brain, tweak those variables around and try to think like, okay, how could this happen with those variables? So
yeah, interesting thought experiment. G. Henry, who asked that question?
H.
Glenn.
Yeah.
I had my first letters correct, just backwards and wrong names.
So I don't know, there's our thought process on the whole thing.
Yeah, that's interesting. That's a good question.
Yeah.
All right, we got time for one more. What do we got?
Anyone else? Any questions out there?
Come on.
Out in the internets,
in the Twitterverse.
If not, can we talk about this fungus thing? I thought that was.
Yeah. Send in the questions, and then we'll talk about this, and then we'll get to.
Sorry, I forgot all about the fungus among us.
Yeah.
Where's this going? What happened?
Oh, do you want me to talk?
Yeah.
So this team led by UNC Charlotte and Stanford, they got a hold of some fungus that is growing inside of the Chernobyl power plant. And I want to say from inside the reactor. Yeah.
Oh, this one. Okay. Yeah.
So not just like in the exclusion zone, in the destroyed reactor, where radiation is, some would say, high. So
rumor has it.
Allegedly.
Yeah. So not only did they find this fungus, but that there's this fungus that thrives, and it is Cladosporium sphaerospermium.
Oh, they're the best shrooms.
Yeah. And so what they did was they cultured it and they sent it up to the space station. Because one of the issues,
So it sounds like
We're
the
gonna
beginning of a
have-
sci-fi movie.
oh yeah. So anyway, it became sentient and it took over the space station.
Exactly. Everyone that comes back is now infected.
Yeah. So one of the issues we're going to have with space flight to, say, Mars, otherwise known as like the lesser of the two planets between Mars and Venus. If we do want to do manned space flights to Mars, one of the problems is, astronauts get exposed to a lot of radiation. You actually get exposed to a lot of radiation if you fly often, if you're a frequent flyer, because the further off the surface of the Earth you are, the less you're sort of shielded from radiation coming from the sun. Our magnetic field does a really good job of protecting us from such hazards. And so NASA and the European Space Agency and JAXA are looking for ways in which to better shield astronauts. And so one of the ideas that these researchers had was using this fungus, which thrives in these high radiation environments. And so they actually put some on Petri dishes to see if it would shield radiation. And they found that, yes, it reduced radiation levels. So they put it on one side of the Petri dish and then put that facing outward and measured it from the other side where it wasn't growing. And they found it shielded 2%. It was reduced 2%. So it's not enough to sort of make a difference, but they're thinking, oh, what if we make it thicker or something like that? So it's sort of this interesting idea where they're using this thing that will grow and thrive and therefore essentially be free. So it's a way in which we don't have to artificially manufacture some sort of shields. So I just thought it was super interesting. I also did not know there is fungus thriving inside of the destroyed, there's this nuclear power station inside this radioactive, the core of this reactor that done blown itself up inside the Ukraine.
It's amazing. Just like,
Yeah.
to quote Jurassic Park, life always finds a way.
Yeah, 25 years.
Yeah.
It's crazy. That was the part that sort of blew me away.
So it's just nuts. Like, where does this fungus live when, like, there's like, so how many spots on Earth are that radioactive? Like, so how does this thing like,
or did it just adapt that quickly?
Well, I just
based on the radioactive gives it a million mutations more than it would normally have, and then that one mutation finally stuck over the last 40 years and boom.
And is it, oh man, I'm bad on fungi. Is it like a chemotroph? Is it gaining, is it just this extremophile that, because you're shut off from light inside there, I'd assume. So
yeah, I don't know. Crazy.
Are fungi photosynthesizers?
I don't think so. They're like mushrooms or fungus, and they grow them in dark houses.
They're heterotrophic, right? So.
Yeah.
Okay, cool.
So then theoretically, all you do is just bring up a bag of spores.
Yeah.
And just line the side of your spaceship with that and just let them grow.
Yeah, that's what they're saying.
Wow.
Pretty
It's
cool.
interesting. It's interesting if they could, pull something like that off.
Yeah.
I know the other one they were thinking about was using human wastes to put, basically you do your business, you put it in a bag, and then you line the side of the spaceship with that, and that's supposed to block radiation as
old poop ship.
Gives swabbing the poop deck a whole new
yeah, exactly.
whole new meaning.
No, but that's true because like even just water absorbs a ton of radiation. So even if you just had like a thin layer of urine, I guess, around your spaceship, maybe that would absorb the radiation.
Yeah. How about that? All right, so let's get to some of these last minute questions here. All right, let's see.
Mark had a question.
Oh yeah, let's get that. Yeah.
So he asks, and I lost my chat because my computer sucks.
Okay. So
But
Mark says, is there any reason why Earth is still tectonically active, but so many other planets have stopped?
Yeah, because we're the best.
There's your answer, Mark. You heard it first. The Geology
Moving
Flannelcast.
on. No, basically, go ahead, Chris.
Well,
go ahead.
All right. So I'll break it. So number one, there's 8 planets. The inner 4 rocky planets. The outer 4 are gas giants. They don't have tectonics. The gas giants don't have tectonics. So now you're limited to 4 planets, and it comes down to size. And this was actually so obviously the smaller you are, the faster it is for it to cool down. And correct me if I'm wrong, but this is the way I was kind of thought it went. And so that's the reason that Mars was considered. Mars is like it's no longer tectonically active because it's a quarter of the size of the Earth. It's thought that it cooled down. But then my question is, I didn't even know. I didn't really know too much about the geology on Venus. And it's interesting that we thought that Venus was how can I phrase this? We thought that Venus was no longer tectonically active, even though it's considered like the sister planet to Earth. And that surprised me. I would have thought that
it is a tiny bit smaller than us, and I'm wondering if that tiny
little bit
adds, or subtracts, hundreds of millions of years to tectonics. I don't know.
Yeah. Why? What happened to Venus? Where did it go wrong?
But I mean, if you have one less blanket on you, are you going to freeze to death faster?
Yeah. Or, it's both frozen. Well, maybe it's not frozen tectonically, but it has a runaway greenhouse. Ah, boy. Boy, oh boy.
But we kind of touched on this in a previous episode. Somebody asked, without our atmosphere, how much faster would the Earth cool? And, without any math or science involved, we all deduced that the atmosphere doesn't, in the grand scheme of things, really doesn't impact the planet's temperature that much. So I would think that even though you had a runaway greenhouse gas on Venus, that really wouldn't have saved the tectonics on the planet for any significant amount.
Yeah. It's good. So at first, I guess for Mark to answer your question, I think at first the thing comes down to just kind of the size of the planet. So there's the main things that keep that a planet retains heat. Number one, it's just from that like initial heat from when it accreted and became a planet. But then it's also radioactive decay is also heating up the inside of the planet. So I guess it's a really great question, but I think maybe it comes down to one of those factors. Maybe one of those factors is just a little off.
Right. You're just a tiny bit smaller. Maybe you had a tiny bit less radioactive material to begin with, and like Dennis said, it's a very hard planet to study because the atmosphere is so thick. We really don't have a lot of this is, I don't want to say speculation. It's just hard to, it's hard to be certain.
Yeah. So yeah, I think that pretty much wraps up that question.
That's a good question.
Yeah. So, all right. Any other last minute questions? I think there was one. Check YouTube.
Yeah. This question about cement crumbling due to pyrrhotite.
Yeah. I don't live in Pennsylvania anymore, so I don't.
So the short answer is no. So I was at first when you said that question, I was like, well, that's interesting because we have an issue with. So I don't know if I'm pronouncing this or pyrrhotite. It's a form. It's like pyrite in that it's an iron sulfide, and so we have issues with iron. So we have issues with pyrite, especially in the northeastern part of the state in the western part of the state where there's coal mining, because you find pyrite, the iron sulfide, a lot of times mixed in with the coal seams, and when you break up the rock, you bring all the tailings out, and that pyrite, that iron sulfide, mixes with oxygen and rainwater, and so you get acid mine runoff, and we have a lot of problems with that in our state. But I wasn't really too familiar with this crumbling, and I was wondering if it was a function of maybe the acidity doing something with the cement. But just quickly sort of reading up on it, it looks like it looks like the iron sulfide mixes with oxygen and water, and it can cause swelling and cracking to occur. And I'm assuming it has to do with acidity, and the Portland cement is you get a lot of times the original way you would make it was you would take limestone and you sort of cook limestone, and you can get cement that way. So yeah, if you make it acidic, you can cause it to sort of crumble. But no, we don't really have too much because we're not using it in our concretes. Usually you see it in areas where quarries that are making the concrete have this pyrrhotite.
Well, isn't the thing too, like when you make concrete, they're looking at what's in there. They're looking at the ratio of materials in there. They know that they're allowed to, because it all comes down to standard. You can't be selling concrete that's like that's subpar, and then all of a sudden, I mean, you're not supposed to.
No, and
buildings start falling down, and all that stuff.
Yeah, concrete is basic. So if you have something that's producing acidity, that would be.
But there's also things that ponzolize. I'm mispronouncing this, but basically, like if you add chert as an aggregate, which is essentially quartz hydride, which again I'm butchering, but essentially there are certain minerals that you can't use as aggregates in concrete because it actually like it almost turns the concrete to like gel, and it essentially ruins the strength of concrete. So you have to make sure you know where your aggregate is coming from for all these concrete plants to make sure that you're like it'll be strong, it'll be fine at first, but it'll start to break down, and over time that concrete will actually weaken and you'll get failure.
Yeah, and Drew telling me here that pyrite actually is in presence of water and oxygen is expansive, and sure enough, that's having your concrete expand after it's hardened.
It's usually no bueno. That's try to avoid that.
No.
Yeah.
Cool.
But that is a PG exam question. You know, you're sourcing aggregate for your concrete plant for a big dam project. And you have this local source that has chert in it, and you have this source that's really far away, but it's, granite or whatever. It's a weird question like that. You have to know that there are certain aggregates you just can't add to concrete or it weakens it. So,
yeah, I knew about that. I didn't know it to that extent, but I did know that people at these concrete companies, they look at the material and they look for certain minerals in there. And if it's within a certain threshold, above a certain threshold, then like, this ain't no good. Ain't no good. That's horrible grammar. This is no good.
this ain't no bueno.
You can take the kid out of Philly, but you can't take the Philly out of the kid right there. All right. And then I guess one last question. Carson asks, what are your favorite fossils? This is like a whole episode. Carson, what did you do? This is this is Pandora's box right there.
The ones that I find, My favorite fossil on my shelf is my Eurypterid, the one I like just happened upon my first geology field trip ever.
Oh yeah.
But I have some beautiful fern fossils from St. Mary's.
Oh yeah, Jesse showed me that outcrop.
St. Clair.
It's St. Mary's is the town, but it's St. Clair Formation. Yeah.
Where's St. Mary's at?
It's right there. It's like an exit off of 322 or something.
It's beautiful outcrop, or not? I mean, not the outcrop. The fossils there, the ferns are just—it's just amazing. Every single piece of shale
The shale pit that we go to is in St. Clair. There's a St. Mary's in Elk County, but
then I apologize.
Yeah,
I thought it was
St. Clair.
St. Clair. It's an amazing outcrop because it's just kind of like it's not even an outcrop. It's just kind of like just this. There's no trees and it's all just shale.
Well, it was a mine. It was.
Oh, was it a mine?
Yeah, it was strip mine.
Yeah.
Above it. Yeah, above it used to be coal, and now it's not.
Okay. Okay, so they took the coal out.
Cool too, because the whole bed is overturned, so you're actually looking at the underside of the bed.
Oh, it's overturned. Oh, I didn't know that.
Yeah.
Oh, how about that?
It's
really cool.
It's really, really cool.
I was actually going to pick that as my favorite fossil as well.
Ah.
Yeah. That'd be
I don't know.
What's the name of the fern fossil? Do you remember?
No, I can't. I should, but it's
Lycopsid,
maybe. I just know that it was. So when you break this fossil apart, you actually get like mirror images of it, and one image. All right, forget it. I'm just gonna grab one. Hang on.
I don't know. I like trilobites. They're pretty cool. I always get a kick.
Trilobites are cool. Big fan of those.
Coprolites. Big fan of coprolites.
I wonder now. Can you put coprolites on the space shuttle?
All right.
Coprolites shield from radiation.
So here's some of the fossils. It's hard to tell, but so on one side you have this like white powdery material, and on the other side you have this shiny black material. And the one side is actually pyrophyllite, which is like this very fine white fibrous kind of material. And that was one part of the leaf structure that actually fossilized with that mineral. And then the other side, like the cuticle layer, that like is actually carbon. It's actually graphite. So the different layers of the actual leaf actually fossilized differently, and that's when you split it open, it splits along that preferential pathway, and you actually get one side that's white and one side that's like shiny silvery. So really cool.
It is a sweet fossil.
It is.
Yeah, Steve, did your video go out? I didn't see any of your video.
Yeah, it's just stuck on me apparently.
Oh, I'm sorry, I suck.
I do. Yeah, I agree with Carson here. Ammonites especially if you get like some pyritization going on in the ammonites, they're just spectacular.
Yeah, that's always really cool to see the pyritized fossils. So shiny. It's just so like shiny. Wow, what is this?
Now, if you mix those pyritized fossils in your concrete, forget about it. Your building's going to fall apart.
Oh, there you go. Full circle.
Full circle. Yeah.
All right. Well, we got Steve fixing his video right now. You want to show him the fossil real fast? There we go.
Yeah. Sorry. Anyway, I don't know. It's hard to see with the computer light, but
yeah, you can make out the fern. Yeah.
You can kind of see how some parts are white, some parts are silvery, and it actually depends on the different structure of the fossil.
Oh, that's cool.
Yeah.
Really neat. Yeah, fossils are always fun. It's always a blast to see them in the rock. All right. I don't think that's pretty much it for the questions.
We can save some for next time too, fellas.
All right. Well, you guys want to wrap things up?
Yeah. Don't forget to check us out on Facebook, Twitter. Subscribe to us on YouTube. Download us wherever you get your favorite podcasts. Always check out the formattingformula.com or YouTube /T/formattingformula.com. become a Patreon member, and you can hang out with us like Mark and Dennis did today. They hung out with us a little bit beforehand too.
I answer some questions with them afterwards.
Yeah.
Um,
Dennis said it was fun. He said it was totally worth it. He wishes he could pay more.
Dennis, don't listen to him.
I may be paraphrasing, but
yeah, so check us out on, let's see, Facebook, Geology Flannelcast, facebook.com/Geology Flannelcast, at Geo Flannelcast on Twitter. And yeah, that's about it. Oh, I forgot to put the Facebook post up about the contest for the your favorite rock in the rock collection. So after we get done, I'm going to put that up on Facebook. If you got it, send us a picture of your favorite rock in your rock collection. And I don't know, we'll pick some winners. It'll be I don't know. We'll see how this goes. Yeah.
Somebody's
basically
getting stickers.
If you send us some pictures of your rocks, we'll send you stickers, basically is what it's going to come down to. So yeah, send us on our Facebook.
Send us on Twitter, your Facebook.
Very good, right?
Yeah.
All right. So I think that's about it for this week. Thanks so much, everyone.
Yep. Thanks for listening.
Another episode next week. Next week's not going to be a live stream. We'll have actually a pre-recorded episode because
sorry,
it's all Steve's fault. Anyways, it doesn't matter.
I have to go out of town, and I'm worried about the internet connection. So
it's fine.
Which is funny, ironic because, my Zoom cut out like 3 times.
There you have it. Yep. All right, everyone. Thanks for tuning in this week, and we will catch you guys next week. Thanks a lot. Bye.
See ya.
All right.